So here we have an optimization problem where a company has started selling a brand new smartphone at the price of 140 minus 0.1x, where x is the number of smartphones manufactured per day. The parts for each smartphone cost $60, and the labor and overhead for running the plant cost $4,000 per day. How many smartphones should the company manufacture and sell per day to maximize their profits? All right, so this is an optimization problem because we are looking to optimize the profit in this scenario. Specifically, we are looking to maximize it. And so in order to determine how to maximize the profit for this scenario, we need to come up with an equation that will represent the profit for this scenario. And so in general, when we're talking about the profit with regards to selling a product, like we are in this scenario where this company is selling smartphones, the profit will be equal to the price of the product minus the cost to produce that product, right? So the amount of money that you gain from creating and selling a product is equal to how much you sell that product for minus how much it costs to make that product. And so if we want to create an equation that would represent the profit for this scenario, we need to figure out the price and the cost in regards to the smartphones in terms of some variable. In this case, it looks like we're going to be using X. And so in this case, we're told that the new smartphone that this company is selling has a price of $140 minus 0.1x, right? That is the cost of one smartphone. And so if we're trying to figure out how many smartphones the company should manufacture and sell to maximize their profits, we need to figure out what that price would be for that number of smartphones. So this price right here, this 140 minus 0.1x, that is the price of a single smartphone. So if we want to have an amount that represents the price of multiple smartphones, we will have that the price is equal to that amount, 140 minus 0.1x, and multiply it by x, right? If this is the price of one smartphone and x is the number of smartphones manufactured per day, we want to multiply that amount by that price. And that will tell us the total price of all the smartphones produced in one day. Now, we also want to determine the cost per smartphone as well. And that is what we are going to subtract from the price to determine the profit. And so if we go back to our problem here, we have that the parts for each smartphone costs $60 and the labor and overhead for running the plant costs $4,000 per day. So the cost is going to be equal to that $60, right? $60 per smartphone. And then we're going to multiply that by X because each smartphone costs $60 to create, or at least the parts cost that much. And so we need to multiply that by X, which is the number of smartphones made per day. And then we're going to add that to that labor cost per day of $4,000. And so we'll have 4,000. And this will represent the cost of the amount of smartphones produced per day for this company. All right, and so now we have the price and the cost for this scenario. And so now we can move those into this equation here to represent the profit for this scenario in terms of X. So we'll have that the profit P is equal to the price, which is X times this quantity. So we'll have X times 140 minus 0.1x, and then we will subtract the cost, which is 60x plus 4,000. So we'll put this in parentheses, 60x plus 4,000. All right, and so now we have an equation in terms of x that represents the profit for this scenario. And so if we clean up our work here, we can now simplify this equation a little bit, and then we'll get ready to actually work on maximizing the profit and determining our value of X, which would be the number of smartphones made per day that will maximize the profit. And so if we distribute this X through this quantity and multiply it by each term, we will have that the profit is equal to 140 times X minus 0.1x squared. Then we will distribute this negative through this quantity, and so we'll have negative 60x minus 4,000. Now we have two like terms here, 140x and negative 60x, that we can combine, and they will become positive 80x, right? 140 minus 60 would be positive 80. And so we'll have that the profit is equal to 80x minus 0.1x squared minus 4,000. And so now we have a simplified version of this profit equation that we can use to optimize the profit in this scenario. And so once again, I'll clean up our work. And so now before we take the derivative of this equation, which is what we need to do in order to determine the value of x that will maximize the profit, we first need to decide what values of x make sense for this scenario, right? We need to determine the domain of this situation. And so if x represents the number of smartphones the company should manufacture and sell per day to maximize their profits, it wouldn't make sense for that value of x to be negative, right? The company won't be producing a negative amount of smartphones. And so we could say that the lower bound for this scenario would be 0, right? The company probably doesn't want to make 0 smartphones, so it doesn't make sense for that to be included, and so we'll have an open bracket. And then what would be the upper bound? What would be the maximum number of smartphones that a company could make? Well, there's really no limit to that, right? The company could make as many smartphones as they like, but at a certain point, it's not going to be profitable for them anymore. So while it only makes sense to make a certain amount to be profitable, the company does have the possibility to make as many smartphones as they like, and so the upper bound would be infinity. There's really no limit to how many smartphones they could make, at least from the information that we were given in this problem. And so essentially what we learn here from this domain is that the only values of x that make sense for this scenario, or the number of smartphones the company should make and sell per day, would be any positive number of smartphones. All right, so now that we have determined the domain, we can now determine what our value of x should be to maximize the profits. And just a quick side note, sometimes when you're doing an optimization problem, you have to set up two equations. You have your primary equation and then your constraint. In this case, we only have one. We did not need a constraint because our scenario is only working with one variable, which is the variable x. If we had another variable that we needed to work with, then we would have also needed a constraint so that we could have a primary equation in terms of one variable, which is what we have right here. Right, our profit equation is our primary equation, and it's only defined with one variable, which is x. And so with that, we are ready to take the derivative of this equation and determine our value of x to maximize the profit. And so if we take the derivative, we'll have that p prime is equal to the derivative of 80 times x. And when you take the derivative of x to the first power, it's just equal to its coefficient, which in this case is 80. And so we will have 80 minus the derivative of 0.1 times x squared. So we'll use the power rule here, and we'll multiply the exponent down, and then subtract 1 from the exponent. So 2 times 0.1 will be 0.2, and then if we subtract 1 from the exponent, 2 minus 1 is 1, so we'll have x to the first power. And then if we take the derivative of negative 4,000, the derivative of any constant like negative 4,000 is just going to be 0. So we could write plus 0, but we don't really need to write that in our equation. All right, and so now that we have taken the derivative of our profit equation, we want to set this equal to 0 and then solve for x, and that will tell us the number of smartphones that the company should produce and sell per day in order to maximize their profits. Right, because what we're doing here when we set this equal to 0 is we are trying to find any critical points for this equation where the slope is 0, which is a point for that function that has the potential to be a maximum or a minimum. And so if we set this derivative equal to 0, we'll have 0 is equal to 80 minus 0.2x. And then if we add 0.2x to both sides, and I'll do that over here, we'll have 0.2x is equal to 80. And then if we divide both sides by 0.2, we will have that x is equal to 80 divided by 0.2. And 80 divided by 0.2 is 400, and so x will be equal to 400. And so this is our value of x, or the number of smartphones that the company should manufacture and sell per day to maximize their profits. And so if you wanted to check to make sure that this answer is correct, you could use the second derivative test to check that this is a maximum. And so all we have to do to check that is find the second derivative of our profit equation. And so we just have to take the derivative again of this first derivative. And so if we do that, we'll have p double prime is equal to the derivative of 80, which is a constant, so that would be 0, and then the derivative of negative 0.2x. and the derivative of x to the first power is just equal to its coefficient, and so the second derivative is equal to negative 0.2. And so for the second derivative, there is no variable of x, and so if you were to plug this value of x into the second derivative to see if it was a negative value or a positive value, there is no x to plug it into, and so you know that the second derivative will be negative for any value of x plugged into it, including this critical value right here. And so, since the second derivative is negative, that means that this critical point is a maximum, right? So another way to look at it is that when the second derivative is negative, that means that we're looking at a critical point on a concave down function. And so that point at the top would be the maximum of that area. And if you're not familiar with the second derivative test, feel free to check out my video that I have on that topic that I'll have linked here for you to click on. It'll also be in the description if you are interested. Okay, but the fact that the second derivative is negative confirms that this value of x is a maximum, and so we can conclude that if the company produces and sells 400 smartphones per day, they will maximize their profits. All right, and so that's it for this optimization problem. If you have any questions, feel free to leave those in the comments below. But if you don't have any questions and you found this video to be helpful or you enjoyed it, feel free to check out some of my other calculus tutorials that you can find on the channel. But for now, this is all I had, so I will see you next time.